Okay, good morning. So today we'll start the ideal and non-ideal solution. You, you might have heard it is a 12th class, 12th board topic, but actually most of the time it is very essential to know for the IIT-JEE and NEET examination also. So we're going to start to the topic. The topic. So ideal and a non-ideal solution. Ideal and a non-ideal solution. Okay. So ideal and a non-ideal solution. So know the ideal and a non-ideal solution. So let us see. So there is a solute and other one is the solvent that make the solution. The solute is A2, solvent is B2, and a solution is AB. So in solute there is a AA bonding is there. In a solvent the BB bonding is there. And in a solution the AB bonding is present. Okay. So you know the solute is the minor constituent. Solute is the minor constituent and a solvent is the major constituent. And we know the solute also called as the disperse phase and the solvent is called as the dispersion medium. So the disperse phase मतलब क्या है? The disperse phase means it is phase, it is spread in the dispersion medium. Okay. So the disperse phase and the dispersion medium, that is the solute is the disperse phase and the solvent is the dispersion medium. Okay. So the solute. So we are talking about the mixture of liquids. Mixture of liquids. So there are two liquids, liquid A and a liquid B. So when they will be mixed, that will form the varieties of solution. That is, the different types of solutions are there. So the solute may be the solid liquid gas and solvent may be solid liquid gas according to the physical state. So the different solutions are there, like the emulsion, aerosols, sol, gel, all these things are there. So in case of the solution, what is the solution is formed? So this we are talking about the liquid solutions. So liquid solution means the solute is liquid and solvent is also liquid. A is liquid and B is also liquid. So when they will mix together, that will form the AB liquid solution, AB solution. Let's take the example. Ethyl alcohol is liquid and water is also liquid. So they will mix, they will become a solution. HCl is a gaseous form, but in the liquid state may be there. But HCl and water mixed together, that become another solution. Chloroform, benzene mixed together, it is your solution. So that's all. That is the solutions are the solute and the solvent. The A is the solute and the B is the solvent. That is called the solution. So okay. So when they will mix together, there are different kind of mixing will be there. Maybe the force of attraction between the solute molecule and the solute molecule, and the force of attraction between the solvent molecule and the solvent molecule, that may be when they will mix together, that become the solution. The force of attraction between the A and the B, that may be remain same or maybe different also. So the remain same, that is, if we say, that is absolutely not possible, not correct. So that's why we'll discuss. So the force of attraction may be increase when they will become solution, or the force of attraction between the solvent and the solid molecule may be decreased as compared to the solute and solvent. Okay. So let us see the solutions is basically two types. One is the ideal solution, another is the non-ideal solution. The solutions are two types. One is the ideal solution, another is the non-ideal solution. So one solution is the ideal solution and other one is the non-ideal solution. But practically if you understand, there is no solution is perfectly ideal. All are non-ideal solutions. But some extent, we consider that it may be ideal. Very close to ideal, not perfectly ideal. So no solution is perfect. Just like you, the no student is perfectly ideal students. All are approaching to the ideal students. Okay. So the ideal solutions. Ideal solution means the solution which obey Raoult's law. The solution which obey the Raoult's law is called the ideal solution. What solution will obey? What is the Raoult's law? Raoult's law means the the relative lowering of vapor pressure is equal to the mole fraction of the solute. So that is the statements of the Raoult's law. What the Raoult's law says? The relative lowering of the vapor pressure. So when the solute is added to the solvent, the vapor pressure decreases. The extent of a decrease, the relative lowering of the vapor pressure is equal to the mole fraction of the solute. So another statement is there. The vapor pressure of the solution is equal to the product of the vapor pressure of the solvent and its mole fraction. Again I am repeating. There is another statement of the Raoult's law. The vapor pressure of the solution is equal to the product of the vapor pressure of the solvent and the mole fraction of the solvent. Vapor pressure of the solution is equal to the vapor pressure of the solvent and the mole fraction of the solvent. Okay. So the ideal solution means the solution which obey the Raoult's law. So here do not obey Raoult's law. It do not obey Raoult's law. So another thing, the force of attraction between the A, what I have explained here earlier. The force of attraction between the A and BB is equal to the force of attraction between the AB. So this sign is given. So it is not perfectly equal, it is very close to equal. The force of attraction between the solute and solvent is equal to solute and solvent. Okay. But in case of the non-ideal solution, the force of attraction between the A and BB is not equal to between the AB. Okay. So the force is not equal to the solute solvent force. That obviously that should be. So when the force of attraction is equal, so there will be neither expansion nor the contraction in the volume, because so the delta V mixing is equal to 0. Means if we take 20 ml of solute and 20 ml of solvent, so that become the 40 ml of the solution. So there is nothing going to change. But in this case, the delta V mixing is not equal to 0. That means if we take 20 ml plus 20 ml, that is not equal to 40 ml. That may be 35 ml or 45 ml. Just approximately. So it may increase or it may decrease. So if it is increased, there is the expansion of the volume. If it is decreased, that is the contraction of the volume. When the force of attraction increases between the solute and solvent, the volume will contract. If the force of attraction between the solute and solvent decreases, then the volume will expand. So that is the expansion of the volume and the contraction of the volume. Okay, clear? So when the force of attraction between the solute and solvent is more, then the contraction takes place. When the force of attraction between the solute and solvent is less, then the expansion takes place. That's why it is not equal to 0. So the delta H mixing is equal to 0. So delta H mixing is equal to 0 means what? Delta H mixing is equal to 0. Delta H mixing is equal to 0. Delta H mixing is equal to 0 means what happens? So delta H mixing is equal to 0 means there is no energy changes. There is no energy changes uh, during the mixing. Okay. So there is no energy changes during the mixing. So energy changes, no energy changes. That means it is neither endothermic mixing nor exothermic mixing. So there is no energy changes taking place. But here the delta H mix is not equal to 0. Means it may be exothermic, it may be endothermic nature. It may be exothermic or it may be endothermic in nature. Okay. So in case of the ideal solution, that is no space is at the bottom, so I am writing it now. So in case of the ideal solution, what will happen? So the PA is equal to PA0 XA. It is very similar to this formula PA0 X0. So the vapor pressure of the solution is equal to vapor pressure of the solvent and the mole fraction of the solvent. PS is the vapor pressure of the solution, P0 is the vapor pressure of the solvent, and X0 is the mole fraction of the solvent. So the on basis of this, the Raoult's law, the PA is equal to PA0 XA and PB is equal to PB0 XP and PT total vapor pressure is equal to PA plus PB, PA plus PB, or we can write the PA0 XA plus PB0 XB. So that is for the ideal solution, and for the non-ideal solution the PA is not equal to PA0 XA and PB is not equal to PB0 XB and PT is not equal to PA plus PB or PA0 XA plus PB0 XB. Okay. So it is not equal, but it is equal. So what is PA? What is PA? And what is PA0? So the PA is the vapor pressure of the liquid. PA is the vapor pressure of the liquid, pure liquid A. So PA means the partial vapor pressure of A in presence of B. Suppose you are staying at a home alone, nobody is there. How it will behave? So that your husband will be there, is no start, etc., and will be freely moving. So there is nobody there to look at you. There is no facing, nothing, no dressing, nothing. So that is the actual nature. So that is the PA0. Suppose your close friend came to your house, then you will take the sun, you will take the sand, etc. So that's you will take the hair cutting and you will take the facial cream, etc. So that is the partial behavior. So your behavior in presence of your friend is PA, and we are staying alone, that is PA0. You can understand now. So what is the PA? PA means PA0 means the vapor pressure of liquid A, pure liquid A, vapor pressure of pure liquid A. PB0 is the vapor pressure of pure liquid B. PA is the partial vapor pressure or the vapor pressure of liquid empty लिखा that is called as the partial vapor pressure, but we can say the vapor pressure of liquid A in presence of B. PA is the vapor pressure of liquid A in presence of B and PB is the vapor pressure of liquid B in presence of A. Now you can understand. What is PA? PA0 means the vapor pressure of pure liquid A, when liquid A only present, nothing else is present. So that is the vapor pressure of pure liquid A. PB0 means the vapor pressure of pure liquid B, when the no other liquids are there. PA is the partial vapor pressure or the vapor pressure of liquid A in presence of B. When B is present, when your friend came to your house, your behavior, your attitude, your action is the partial actions. So PB is the vapor pressure of liquid B in presence of A. So that is called the PA. And XA is the mole fraction of A in liquid. XA is the mole fraction of A in liquid phase. And XB is the mole fraction of B in liquid phase. XA and XB. So now you try to understand. Sometimes the problem will ask to calculate the total vapor pressure, and PT is what? PT is the total vapor pressure of mixture of liquid A and B. PT is the total vapor pressure of the mixture of liquid A and B. Okay. So let me explain again. In case of the ideal solution, the PA is equal to PA0XA. In case of the PB is equal to PB0XB, that is as per the Raoult's law. PT is equal to PA plus PB, and PT is equal to PA0XA plus PB0XB. So the mole fraction of A in a liquid phase, XA is the mole fraction of A in a liquid phase, XB is the mole fraction of B in a liquid phase, and a PA0 is the mole fraction, means you understand, is the fraction of individual mole in total mole, that is called the mole fraction. PA0 is the vapor pressure of pure liquid A, PB0 is the vapor pressure of pure liquid B, PA is the vapor pressure of liquid A in presence of B, PB is the vapor pressure of liquid B in the presence of A, that is the partial vapor pressure of A and the partial vapor pressure of B. So this is for the non-ideal solution and this is for the ideal solution. So now we will discuss detail for the non-ideal solution. First, let us see some of the examples. Some of the examples of the ideal solution. So the example is the benzene plus toluene mixture. That molecular mass slightly equal. So another is the N-hexane plus N-heptane. So that is very close nature. So that's we can say that is the ideal solution. Chlorobenzene plus bromobenzene. Chlorobenzene and bromobenzene. This is also an example of ideal solution. Ethyl bromide plus ethyl iodide. So these four are the, as I told, this is not the perfectly ideal solution. No solution is perfectly ideal, but they are approaching to the ideal natures. Okay, so these are the examples of the this solution, that is the examples of the ideal solution. Now we will see the graphs. Now we'll see the graphs. You see, for the ideal solution. This is for ideal solution. In case of the ideal solution, we will plot the graph between the vapor pressure and the mole fraction. We are plotting the graph between the vapor pressure and mole fraction. So this is the XA is equal to 1 and XB is equal to 0. You know the sum of mole fraction is always equal to 1. Sum of mole fraction, the fraction of individual mole is the mole fraction. XA plus XB is equal to 1. If XA is equal to 1, then XB is equal to 0 because sum will be equal to 1. So that is the state of pure A state. So the XA gradually decreases and that XA becomes 0. xp gradually increases, that is xp is equal to 1. That sum is equal to 1. So this is the state of pure B. Here in this condition, this side, so that is the pure A is present. But in other side, the pure B is present. So when the pure A is present, the vapor pressure is called as PA0. When the pure B is present, the vapor pressure is called as PB0. But as the mole fraction of the A is 100% here, 1. So it gradually decreases, so the vapor pressure is also gradually decreases here. So here xp is 0, but xp is equal to 1. So gradually vapor pressure will increase. So it will reaches here. So when the PA value decreases, then the PB value increases. So this is the line will represent the PA and which is equal to PA0 XA. And this is the line, this is the pure B here. But this is the line where the PB is equal to PB0 XB. So this line represents the partial vapor pressure of B. This line represents the partial vapor pressure of A. But if you put the line here, so this will represent the PT, that is the PA plus PB. You see, this is the, suppose this is the PT. If we put a line here, this represents the PA up to this. Up to this is the PA. And this is the PB. If we add here, that becomes PT. Because the PT is equal to PA plus PB, or it is the PA0 XA plus PB0 XB. Okay, so this is the ideal solutions, graph for the ideal solution that obey the Raoult's law. If it is do not obey the Raoult's law, then what will happen? You can say if it not obey, either it will be give the positive deviation or it will give the negative deviation. So either the graph will be upward or maybe downwards. So that is for non-ideal solutions. So this graph you try to understand. If you want, I can explain it again. You see. So this is the plot between the mole vapor pressure and mole fraction of the liquids. This is the vapor pressure along this line, and this is the mole fraction. So the mole fraction Xa is equal to 1, the mole fraction of A is equal to 1 and B is equal to 0. That means the pure A. Here Xa gradually decreases to 0 and Xb from the 0 gradually increases to B1, means 100%. So here pure A and here the pure B. The pure air vapor, the vapor pressure pure A, that is the PA0. The vapor pressure pure B, that is the PB0. That is the PB0. So the PA0, so it gradually decreases to 0 here. Vapor pressure becomes 0 because there is no A will be there. But here the PB gradually increases. So along this line, this is the PB, partial vapor pressure of B. And because this is the vapor pressure of B in presence of A. This is the vapor pressure of A in presence of B. That's why this is the partial vapor pressures. Okay. So this is the graph for the ideal solution. Okay. So slightly I will erase it. So now you see for the non-ideal solution. Non-ideal solution is two types. Non-ideal solution is two types. One is gives the positive deviation. One positive deviation from Raoult's law. Positive deviation. Another negative deviation from the Raoult's law. Negative deviation from Raoult's law. The positive deviation from the Raoult's law and a negative deviation from the Raoult's law. So the positive deviation from the Raoult's law and a negative deviation from the Raoult's law. So if you see the difference here, So here in the positive deviation means the vapor pressure will be more. The vapor pressure will be more means the force of attraction definitely less. So for the positive deviation, the force of attraction between the AA and a BB is less than is more than the force of attraction between the A and B. The force we gain. So in this case, the force of attraction between the A and BB is less than AB. So that means here the force of attraction will be more. Here the force of attraction is less. Here it is more. The force of attraction less means when the force of attraction decreases, the what happens? It increases. When the force of attraction decreases, the vapor pressure increases. When the force of attraction increases, the force of attraction decreases. If the vapor pressure decreases. So that's why it gives the positive deviation. So here the delta V mixing, it will give the expansion. Delta V mixing is greater than 0 because the force weaken, the expansion takes place, expansive. But here the delta V mixing is less than 0 means it will give the contraction mixing. Volume will contract. So once the question also asked in the entrance examination. So when the chloroform mixed with the acetone, once it was asked in one examination that I recall, the 20 ml chloroform mixed with the 20 ml of acetone, so what will happen to the volume? It will be 38 ml, it will be 40 ml, it will be 45 ml and none of these. What of answer? What will be the answer? So the volume will be contract because during this case what will happen? So this a hydrogen bonding will develop here. Let me explain here. So this is the chloroform molecule. Though this hydrogen atom not able to form the hydrogen bonding, but because of the three chlorine atom is attracting to that, because of the strong attraction, this hydrogen develop electropositive character and make the hydrogen bonding with oxygen. Because of this bonding, the contraction in the volume takes place. Because of the contraction in the volume will decreases. On 20 ml mixed with 20 ml, that become not 40 ml, it become 38 or 35 ml. That is the volume contraction there. That is just for your understanding and the example also. So that is the contraction mixing. So the another one is so the delta H mixing, the enthalpy. The delta H mixing is less than 0. It's greater than 0. Greater than 0 means it will be endothermic mixing. So that means endothermic mixing means the heat is required for the solubilization. We have to give the heat to mix it. We have to stir. We have to heat it so that it will dissolve. So for that solution, we have to apply the heat. Otherwise, this mixing will be not possible. So the another one is that here the delta H mixing is less than 0. That means it will be exothermic mixing because heat will be generated there because the force of attraction is increasing. When the stronger is the force, more energy is released. That is the nature of chemical reaction. So when the stronger is the force of attraction between the two atoms, the more energy due to the bond formation, the energy release. Because the bond is weakened here, it needs the heat. So in this case, what will happen? The PA is greater than PA0 XA, PA0 XA, and PB is greater than PB0 XB. Here the PA and the PT is greater than PA plus PB. But here is the PA is less than PA0 XA and PB is less than PB0 XB. And PT is less than PT plus is a PA plus PB. Okay. So what do you understand here? What do you understand here? So from the pH greater than the pH greater than the PA0 XA and PB is greater than PB0 XB. So let me draw the graph for the understanding. Let me remove these things to explain the two graphs we have to draw. Two graphs, so that is for the positive deviation and this is for the negative deviation. So this is the vapor pressure. As I have explained, this is the mole fraction, this is the vapor pressure and this is the mole fraction. So in this case, this is the Xa is equal to 1, Xb is equal to 0, Xa is equal to 0, Xb is equal to 1. So it is decreases and it is increases. Okay. So this is the pure A as I have explained. If you have any doubt, you can follow this graph also. Scroll it out now again. So this is the PA0 and this is the PB0. So it gradually decreases to 0. This is gradually increases to PB0. And this is the total vapor pressure. This is the PA, this is the PB and this is the PT, that is the PA plus PB. But actually what happens, because there is positive deviation from the Raoult's law, so the PA is greater than PA0 plus XP. So greater than means it will be upward. So it is also greater than this. As I written here, it is greater than that. So total vapor pressure is also greater than this. And here also you can understand the X is equal to 1, Xb is equal to 0, X is equal to 0, Xb is equal to 1. That is the pure B and this is the pure A. So this is decreases and this is increases. And it is the PA0 and it is the PB0. The graph will decreases gradually. It will increases and this is the total. This is the PT, this is the PA and this is the PB. This is the PV. So the what will happen? So here the negative slope. It is the less than. Less than means the graph will be like this. Okay. Very well you can understand. It will be like this. So this is the negative deviation and this is the positive deviation. This is the negative deviation and it is the positive deviation. So only things is left is, so I have to give some examples. Example of the positive deviation and examples of the negative deviation. Negative deviation and it is the positive deviation graph. Negative deviation and a positive deviation graph. Examples. So the negative deviation means the force of attraction is more. The one of the examples what I have explained, the chloroform and the acetone. So because of the hydrogen bonding, the force of attraction increases here. Other examples like the water, HCl, other example like the water and HNO3, like the chloroform. Okay, these are the few examples. They are the few examples. Water plus acetic acid, water plus acetic acid, that is many examples. So here the force of attraction can increase, the polar solvent dp-dp interaction will decrease. So these are the examples where the force of attraction increases, like the chloroform and benzene, that also. And positive deviation, that is a force of attraction is less here. The example is the chloroform cyclohexane, like the chloroform and cyclohexane, like the water and ethyl alcohol. Water and ethyl alcohol. That is also an example. Water and ethyl alcohol, carbon tetrachloride and carbon tetrachloride plus chloroform, because one is polar, another non-polar. Cyclohexane plus acetone. Cyclohexane plus acetone. The cyclohexane plus ethyl alcohol. These are the pure. One is polar, another is the non-polar. That will form the positive deviation solution, and that will form the negative deviation solution. These are the different example. You try to understand the graph in JEE Advanced also the question asked in the graphical questions will be there, and in the board exam also, NEET examination also, that is this things will be very essential. So I hope you understand it perfectly, and my request is you must subscribe the Barik Sir Chemistry in YouTube channel. So that will encourage me. So hope you understand, and azeotropic mixture and all other things I'll explain in the other video. Thank you. Okay. Have a nice day.